To start off our Rube Goldberg machine, we will have someone pull back this green boot, hitting this ball along this wooden track. We'll go across our machine, hitting this roller coaster along these circular tracks, and this roller coaster will hit this one. Then this one will hit this stick, flicking this switch, turning the motor on. This motor will spin this axle, which is connected to this gear. This gear is connected to this gear by these chains, and this will spin this arm. Once the arm is out of the way, this water bottle will fall down, releasing the ball from inside of it, out the front, into this tub-like funnel. It will fall through the tub, down this slide and hitting this wooden plank. The wooden plank will then hit William Shatner in the face, and will release this gate. Thomas the Tank Engine will then roll down this path, hitting this large marble. It will roll along this inclined plane, hitting these 5 smaller marbles, which will fall into this pipe. The 5 balls will fall down this pegboard, roll down this path onto the mousetrap. This will pull back this string, pulling back the trigger, launching a nerve gun across the room. And that is our Rube Goldberg machine.
In our project, the forces we use are fairly basic. We generally stick to 3: the force of gravity, applied force, and the force of tension. Right here, as the boot goes down with the force of gravity, it hits the marble with applied force, forcing it to go down the rest of this track with the force of gravity. The force of gravity then has applied force onto these carts. The carts go down because of gravity. And then right here we have our first example of electrical energy. Once the switch is switched because of applied force, it completes the circuit, and the electrical energy spins this axle with the applied force, releasing this. And the water bottle will go down because of the force of gravity, pushing down this plank, then this book. Then the force of tension will be applied right here to Thomas the Tank Engine, forcing him to go down because of the force of gravity. And then the balls rolling down the inclined plane, once again to the force of gravity. This continues through the pipe and the pegboard. Then all of a sudden we have the mousetrap with the force of tension on the spring, then the force of tension on the metal wire, and then applied force right on the gun, forcing the bullet to fly across the room. Those are the forces in our physics project. Thank you very much.
Alright, for our Rube Goldberg machine, originally we just had someone push the ball, but we decided to add a boot to it, and the boot is hooked up to this lamppost looking thing to give the boot something to swing on. And then we have the track here, which it rolls down. We didn't have too many problems with this except for the part near the end. Here it would sort of tilt upwards and it would block the ball from coming by, so we just had to staple it down and hot glue it down and everything. Next we have the roller coasters. It took a while to get the design for it. We had to find the right place for the support, what we're going to use to support it, and thankfully we have this wooden piece here that it can stick onto, and we just had to find a way to use tape and everything to support it properly. And the same thing goes with the second part. For the stick, we just had to line it up properly so that it would turn on the motor. And with the motor, we actually had problems because there were no metal plates around these parts, so we ended up using tin foil. We put tin foil on it and then we taped it a lot so that it wouldn't move at all, because the metal plates would complete the circuit, but if that wasn't there, it wouldn't work, so tin foil worked fine for that. And we have the gears, which originally there were some problems because they would slide around, but we created this bracket type system that would hold the gears in place so that they wouldn't slide around. And next we have the water bottle. As you can see, there were a lot of problems with the ball leaving the water bottle. A lot of times it would go, when it fell down, the ball would fall out before the funnel or would fly off to one of the sides. So there were several times where we just had to continue redoing it and just taped on a ton of pieces of Lego so that it would block every possible way that it would fall. And we also had to extend the stick we had to extend the stick because it was too short. As you can see there, it wouldn't, the stick holding it up wouldn't, like, the stick wasn't long enough to be held up by the support. And the funnel, there were a couple problems. There weren't too many, but there were a couple problems holding it up. We just had to find the proper support and build up the Lego to the perfect height. And next we have the ramp, which we just had to line it up properly. And the support, I was afraid it would be a little bit too tilted and it wouldn't hold it up properly, but it worked fine with enough hot glue. And then the track piece here knocks down the book, and it took a while to find a good book that was like sized and weighted properly, and it's just taped down so it doesn't open up randomly. And the next is the string leading to what blocks the tank engine from falling down. Originally it was down here, but the problem was whenever it was pulled away, it would pull with it. It would pull the Thomas the Tank Engine off the track. So we added Lego here, and then we have the inclined plane here, which we used the wood and the Lego pieces to hold it up so that it would have a steep enough plane to roll down. And then we just added a bunch of marbles so that it would look better for later on. And then we just had to figure out how we could transport the marbles toward the middle, because that's where we were locating the pegboard. So we just ended up figuring out that we could just use a tube, which transports them to the pegboard. It took a while to make the pegboard, but we didn't have too many problems with it. And then we just had this inclined plane leading to the mousetrap. And originally it was a basket which all the marbles would fill up, but there was a big problem because the Nerf gun, because there's a pulley system and the marbles with the basket did not weigh enough to pull the trigger. So we ended up figuring out that we can use the mousetrap eventually to pull the trigger, and it would have more than enough force to shoot the gun. Okay, so for a Rube Goldberg machine, to plan it out, we just had a ginormous piece of paper and we took out sticky notes, and every time someone had an idea, we just write them down. As you can see at the bottom, we have a lot of ideas that we thought of but we didn't end up implementing. We just had to decide which steps we should implement them, depending on the situation, where it is, and how we would. The hardest part was finding a way to transition the motion from the bottom to the top of our project.
While working on this project, we went through many obstacles. For instance, group absences. During our work periods, we had various members show up to work in small groups as two to make sure that we could get our work done, but on average we had around 4 or 5 people. Either way, almost every day there was at least 2 people working on the machine. Other obstacles included working through the ice storm. In fact, during one of our work periods, there was a power outage and we had to improvise using flashlights and the LEDs on our cell phones. However, we still got the job done. During the building of the machine, we encountered some issues regarding where parts would go or how we would execute the steps of reaction to the next step. We all had different opinions on what should do what and where it should be put. That said, all of us ended up agreeing on someone's idea to figure out how it worked, and it was for the better. For example, the water bottle step. The water bottle step caused some stir on where the water bottle should be swung or where it should be put. We figured out that combining the ideas of the slide and the bottle together will end up being a well-executed step. In the end, this project challenged our friendship, so we came out stronger than ever.
Okay.
The end.